In physics, units are very important. The International System of Units, abbreviated to SI, is a scientific way of showing the size of things. We're not going to use all 7 base units in Year 10. In fact, you won't even use all 7 base units in GCSE Physics. But we are going to use some of them, and lots of other units that have been derived from them. Derived units are a combination of the base units, and they're used to express a physical quantity of something. So, for example, speed is the unit of the distance travelled for every unit of time, the distance travelled per second. So the derived unit for speed is metres per second. There are 13 different units that we're going to look at this lesson. Some of them will be familiar to you, others may be new. Let's have a look at each one in turn. Distance is measured as a standard in metres. So this can be a distance that includes things like the height of something or the length of something. Distance in metres. So although in the real world you might measure a distance in miles or you might measure a very small distance in millimetres, the standard unit is the metre in physics. Mass is measured in kilograms, mass being the amount of matter. Time can be measured in loads of different units. It can be measured in hours, it can be measured in light years. However, as a standard, we measure time in seconds. Frequency is the number of waves per second, and we'll look at it a lot in topics 4 and 5 this year. The standard unit for measuring frequency is the hertz. 1 hertz is 1 wave per second. Forces. All forces, weight, upthrust, tension, push, pull, loads of different forces I could mention, but they're all measured in a standard unit called the Newton. Energy is the first topic we're going to start with, so this standard unit we will use next week. The standard unit for energy is the joule. Speed and velocity, and we'll see the difference between those in topic 2 this year. Speed or velocity is measured in metres per second. How many metres you go every second. Acceleration is the rate of change of speed. It's how many metres per second you go per second. So we measure acceleration in metres per second squared. The gravitational field strength. Now this is a tricky one to get your head round. We represent gravitational field strength with the letter little g. And gravitational field strength is measured as a standard in newtons per kilogram. So that means it's the amount of force in newtons being pulled on every kilogram of mass because of being in the gravitational field of some other object. We normally think about the gravitational field of Earth, where 10 newtons pulls on every kilogram. However, because this mass is being pulled with a force, it accelerates. It accelerates because of gravity. So this little g is sometimes called the acceleration due to gravity, and then it would be measured in metres per second squared. It would still be 10 though. Little g is always worth 10. But sometimes the unit is newtons per kilogram, sometimes it's metres per second squared, depending on whether they're referring to it as the gravitational field strength or the acceleration due to gravity. Charge. You might not have seen this unit before. Electric charge is measured in a unit called the coulomb. Electric current is measured in a unit called the ampere, but we tend to say current is measured in amps. 1 amp is the same as 1 coulomb of charge flowing every second. So 1 amp is 1 coulomb per second. Potential difference is measured in a standard unit called the volt. That's why you might have called potential difference voltage in the past. Potential difference is measured in the volt, which is a derived unit. It's derived from the definition of potential difference. It's the energy per unit of charge. So potential difference is measured in the joules per coulomb, the amount of energy in joules for every coulomb of charge. 1 volt is 1 joule per coulomb. And our final unit of focus today is the standard unit for resistance. That's the ohm. The funny horseshoe symbol that you can see is the Greek letter omega. So that's task 1 complete. I've read through the information and expanded on it for you in this video. I hope you found that useful. Now you need to move on to task 2 and make some revision cards, some flashcards, and there are instructions for you on exactly how to do this. And then you're going to practice using those cards to learn these 13 units that are important for year 10 before you finish by showing me how you've got on in a quick little multiple choice assignment that I've set for you. Good luck with the rest of the lesson.